Hello students, I wanted to include this little video here to support the module 11 programming assignment, in which we have an array of movie records. And this array is not just an array of movie records, but it's an array of pointers to movie records. So the example that I have here, which is very close to the work that you will be doing in module 11, consists of a student, which is described as a record, and that's given in the header. So a student is described as an entity with a name and a student ID. This is very similar to the movie record. The things that we're going to do is we are going to create an array of student which contains pointers to student records. And then all we're going to do is populate the pointer array by reading the information from a data file and displaying it. So when we go through both of these methods, this will give you sufficient ammunition to very easily tackle the programming assignment 11. The one thing I'd like to point out is the inclusion of memory. Some of your IDEs may include memory. Replit works without it, but for sure there could be other IDEs that need it, so it would be wise to include that. The other thing I wanted to point out is here. For example, when you create an array of pointers, the only difference to the regular array, and I would encourage you to read all of these comments that I've included in this example file, is that you would include a star here. That is the only difference to creating an array of pointers. Now I'm creating an array of pointers to student records. I have already defined student as a record. And what I'm doing here is I'm populating the pointer array and displaying the pointer array. In my example, I have size, which could be less than number of students, but you don't need to worry about it. The main thing you need to worry about is how am I populating and how am I displaying. In order to see that, let's go into the student header, which simply contains the header to the functions, and now on to how have I defined these functions. Now in order to populate, of course the first thing we do is open the file, check and see if we've opened it successfully. And then this is the key addition. What I have here is I'm creating a temporary record, and I'm creating it in an area of memory called heap. And when I use the keyword new, this means fetch me a fresh record from the dynamic area of memory. And that's how I have created just one single record. This is just one single record, and so student is a pointer. Student is a pointer to a record which contains a student's name and a student's ID. So student is a pointer, and that's how you indicate. The star indicates that you've created a pointer to a record. Now what I'm doing here is I'm filling from the file, I'm filling information into this temporary record. So for example, if I look into my data file, I see that the student name and the ID is right here. So in the first instance, this is going to contain, I think I just lost my thing here. Student is a pointer. When this loop executes the first time, then Hector's name is going to go into this, and his ID 3421, whatever that is going to get stored here. So I fill this record. And how do I fill it? I fill it by using the arrow notation. The only difference you will make to your movie access is you used dot, and now you're going to have to change dot to arrow. Why do we do that? Because student is not a record, it's a pointer. And so in order to access the actual record, we are going to have to dereference the pointer. The arrow notation is a short form for star and dot. So instead of saying star student, so dereference the student, dereference, I go to the place where the record actually exists, follow the address, and then access the field, name field inside that record. Star and dot combined, there is a short form for that, and that's arrow. So it's equivalent to saying student arrow name. So that's the only change that you will make. You will make that change. Wherever you access a movie field, you will change that to the arrow notation. And of course, the last thing that I do is assign my pointer, the pointer array that I'm populating, I assign the address inside my pointer array to the address of students. So if I have an array and this array contains pointers, then basically what I'm doing is I'm creating records from the memory, which could be anywhere in the memory, and then each one of them is getting set to that particular record wherever it exists in the memory. So the array of pointers points to the individual records, and these individual records may be scattered all over memory, and that's what the dynamic memory allows us to do. And that's the benefit of pointers, is that if our objects are very large and we don't have place to create an array consisting of literally millions of large objects, which all need a huge storage space that is contiguous, and that's not always possible, we create an array of pointers, and this array is small because it just contains the addresses, but these addresses point to locations in the memory wherever space is found for that particular object. So the last thing that you're going to have to do is to do this. There is another way to do this as well. What you could do, is do this in the beginning, do pointer array size equal to student, and directly fill, instead of filling student, you could just fill pointer array and then do size and then you could do name. You could do this as well. So movie array size arrow name. You could do this as well. So the two ways of doing that are either you create a temporary student record, fill that and assign that to the pointer, or create the temporary record, assign the pointer to that, and then fill the pointer directly. So any of these two methods would work. Now, I'm just going to erase all of this. So how does display work? Let's go to display. Just trying to see if I can actually, So all that we're doing in the display is we are accessing the fields of the pointer array with the arrow notation, right? So the display is very simple, and when I run this program, it picks up from the file and displays it. So this would be helpful to you. These are just a few small changes that you need to make to your work in Module 8 to convert it to a workable solution for Module 11.